The main objective of Toughsteel was to disseminate and promote the use of fracture toughness in the sheet metal sector. This property has shown to be really useful to understand different crack-related phenomena in the use and application of advanced high-strength steel sheets.
To assess fracture toughness in metal sheets, we have used the methodology of the essential work of fracture, and it consists of dividing the total work needed to create a fracture into two parts. One is the essential work of fracture to create two new surfaces of a crack, and the second part that we can obtain is the non-essential plastic work. The assessment of fracture toughness can help the different sectors such as transport, and in this case we can go from the material developers to stampers or the final automotive companies, and we can assess them in the fracture problems that can arise in their processes. In the Toughsteel project, we have contacted 5 different companies where we have assessed them in different edge cracking or cracking related problems. We could help them understand the cracking process and at different levels, from metal producers to forming companies. With this methodology, we can understand and help them to understand this different behavior that sometimes it's not well described with the traditional mechanical properties, and it's a new parameter that can be introduced to the industry to understand these new materials that are being developed.
With our case study was to test 5 different hot-rolled materials from SSAB, make the essential work of fracture tests, really see that are there any differences in the fracture toughness properties, and the results are really promising. We got really distinctive differences between the materials, and now we should just understand how to influence these properties.
We faced some unexplained cracking at one of supplier plants in Portugal, and so we have different batches of material, and we are not able to find, in fact, the root cause. We try, in fact, to launch some material lab testing, but it was not really consistent. We didn't find the root cause. We had a chance to reply to the open call, and finally the tests were investigated by the EURECAT laboratories, and we were able to correlate, in fact, the crack with the energy measured during the essential work of fracture. It was very satisfying because the batches are really sorted according to their essential work of fracture properties.
We were facing some random fracture quality problems with different coils with good quality parameters. This Toughsteel open call was an opportunity for us to try new tests and understand better the behavior of the materials. Thanks to the Toughsteel results, we find out some explanations about this strange random behavior of the materials.
We were able to define a link between fracture toughness and fatigue behavior of steel wheel. And the fracture toughness and also other steel characteristics like UTS, yield stress and elongation can be a potential instrument to predict fatigue behavior of the wheel.